So today we're going to be covering polynomials, factor, and remainder theorem. So I had this chapter specifically requested by a friend of mine. If you have any chapters that you would like to see covered on this channel, please do write them in the comments. I'm checking my comments regularly and I'll have a video up as soon as possible. Right now life is a little busy, but I'm still prioritizing this channel. So we're going to be covering polynomials, factor, and remainder theorem. I'm going to separate the topic right here. So what is a monomial and what is a polynomial? A monomial, or whatever way you want to pronounce it. So I'm going to represent that as monomial. This is basically an equation which only has one term of x, one term of y, one term of z, a, b, c, d. For example, 4x or 4x squared or 4xy. All of these are examples of monomials. A monomial is basically an equation that only has one term. This is one term, right? This is one term, 4x. This is also one term, and this is also one term. Each of these is a monomial in its own right. So what is a polynomial? Well, you should know this already from, you can guess right now. Polynomial is an equation that has more than one term. So it would be 4x plus 3, 4x squared plus 3, or 4xy plus y, for example. Two terms, so that's a polynomial, not a monomial. This can go to 3 terms, 4 terms, 5 terms. The list keeps going on. So let's move on. Now, what is a factor and remainder theorem? So the factor and remainder theorem basically states that polynomials, these equations over here, they all have a factor. And let's understand what a factor is. So a factor is basically a number which you can divide another number with. Now that's a very horrible explanation, but I'll show it to you right now. Say we have 6. What two numbers do we need to multiply each other so that we get 6? 3 and 2, right? 3 is a factor of 6, and so is 2. So when you write 6 in terms of its factors, it will be 3 into 2. So the factor and remainder theorem basically states that the polynomial has its factors. A polynomial can be split into its factors. Imagine this is the equation and imagine this as the factors of that equation. So 6, one factor is 3, the other factor is 2. So how do we relate that to polynomials? Well, let's look at an equation like, I'm going to erase this. So I hope you understand what a factor is. That's basically what a factor is. So let's write a polynomial. Say I want to write x squared plus 4x plus 4, let's say 4. Very simple. So say the examiner says that one of the factors of this equation is x plus 2. Remember how we managed to decompose 6 into 3, which is one factor, and 2, which is the other factor? We can similarly decompose this entire equation into its factors. How do we do that? We already know one of the factors. You know how 6, one of the factors is 3? Here, one of the factors for this polynomial is x plus 2. So we can decompose this into x plus 2 and the other factor, which we don't know here. So you can see over here, 6 does not just have one factor, it has 2 factors. Right now, we've only uncovered one factor. What's the other factor? How do we find that other factor? And how we would do that is we need to know how to do synthetic division. So synthetic division is a bit tricky. You know, it's very error prone. People can mess it up really easily, in exam pressure. So say in a theoretical situation, we know one of the factors of 6 is 3, but we don't know the other factor. How do you think we can find the other factor? Well, it's simple, right? You just divide 6 by 3 and then find what comes over there. So 2 over here, we get 6 and then that's 0. So the other factor is 2. Right, so we can apply the same, we can also divide polynomials by specific terms, and this is known as synthetic division. Okay, so we know one of the factors is x plus 2, so we would divide this entire equation by x plus 2. how do we do that? So x plus 2, x squared plus 4x plus 4. Okay, so first step is systematic division. I want you to take the highest power that's underneath this little bracket or little house thing that we made. I want you to take the highest power of x. The highest power of x, the term which has the highest power of x here, the term which has the highest power of x is, x squared. So I want you to just move it over here, x squared, and I want you to divide it with the highest power of x that we have outside of the house. Outside of the house. The highest power of x outside of the house is just normal x. So I want you to move that over here. Divide them. So this becomes normal x. X squared over x is x. So you should know that. And I want you to put this over here. Now what I want you to do is multiply this with each number here. And move whatever you get after multiplying over here. So x into x is x squared, and x into 2 is 2x. Now I want you to convert the signs. So this is positive x squared, so I want you to turn that into negative x squared. And this is positive 2x, so I want you to convert that into negative 2x. And I want you to just, perform simple addition, subtraction. So 4x, although this is positive over here, we had to switch the signs. So now it's negative 2x. So 4x minus 2x, it's going to be 2x. And you move this like normal over here, plus 4x. Right. So, and x squared minus, this is positive, but we turn the signs, so it's negative x squared. So x squared minus x squared, they cancel each other out, and you're left with 0, so we just don't write that. So 2x plus 4. Now I want you to repeat the whole process, just rinse and repeat. Take the highest power of x inside the house, which is 2x. The highest power of x. Say theoretically this was 2x squared and this was x, just as an example. You would still take 2x squared because that has the highest power of x. Right, I can get rid of, just not to confuse you guys. Let's move on. Okay, so we take the highest power of x inside of the house, and then we divide it. I move it out, and then I divide it with the highest power of x outside of the house, which is x. So they cancel, and we're left with 2. Now I want to move this over here, plus 2. And then I multiply it, and then I repeat the whole process. I multiply 2 over here, and I multiply 2 over here. So we're left with 2x plus 4. Convert the signs, so this becomes minus 2x, and this becomes minus 4. So that eventually gives us 0. So also you should know that when you divide something, and when the remainder is 0, that means it's a perfect factor. When the remainder is 0, it's a perfect factor. Remember when you divided 6 by 3? We managed to get remainder of 0. That shows that this and this, they're perfect factors. They're perfect factors of this number. So we now know that the other factor of the number is x plus 2. So that was the basic process of so now that we know that x plus 2 is the other factor, we just move it over here in the area of the question mark. And I'll do that right now. So now that we know that the factors of this are this. We could have just done this via simple quadratic equation solving, but this will help a lot when we're dealing with trinomials. Not trinomials, but what I mean by that is these equations, cubic equations. Now, we're not required in the A2 syllabus, we're not required to know how to solve these cubic equations. We'll probably know that, understand them in university or something. But as far as the A2 syllabus is concerned, we aren't supposed to know how to solve these cubic equations. What they will do is give us a factor, and then we have to solve it. So say they give us, solve this. Remember how we used to complete the square and everything? This is the same thing, we're just finding the other factor. So you can equate this to 0, and we can say that x is equal to negative 2. Similarly, we're going to be solving cubic equations the same way. So the main takeaway of this video is what does being a factor of a polynomial mean, right? I hope you got that. What being a factor of, this is a factor of a polynomial, and so is this. How to find the other factor of a polynomial when you know one factor via synthetic division, and how to use it if they ask us how to solve the equation. In the next video, I'll be covering cubic equations, how to take factors from those, and how to solve cubic equations using factors.